Alright, let's do this one. Now we have distribution on both sides. We've got this one, 2 times the 3z and 2 times the negative 4. And then we have this one over here, 3 times the z and 3 times the 1. Okay, so 2 times 3z is 6z. 2 times negative 4 is negative 8. And that's plus 1 equals 3 times z is 3z. We had 1, now we have 3. 3 times 1 is 3. Okay, so we have no terms to combine on the right side here, but on the left side we do. We combine the negative 8 plus the 1. Those are like terms. And that gives us a negative 7. So we have 6z minus 7 equals 3z plus 3. Okay, so now we want to get our variable terms on one side and our constants, our numbers, on the other side. So let's do one at a time. Let's bring our constants, our numbers, over to the right side. Well, we're not bringing them over. We're going to eliminate them on the left, and that will put all constants on the right. So to do that, we add a 7. We have 6z minus 7 plus 7 equals 3z plus 3 plus 7. And this one gets eliminated, and we have 6z equals 3z plus 3 plus 7 is 10. Okay, let's do the same thing now with the variable terms, but we'll get them to the left side. We'll subtract a 3z, or add a negative 3z. So I'll do that right here. Negative 3z, add a negative 3z, and on my right side, the 3z and the negative 3z eliminate each other, so we have 10. On the left side, negative 3z plus positive 6z is 3z. Now we divide by 3. Now we're in our multiplicative property, and we end up with a z equals 10. That's a 10 thirds. This next section is about clearing fractions and clearing decimals from linear equations. It's much easier to deal with integers, negative 3, positive 7, 10, instead of sevenths and sixths and eighths and adding fractions together, or adding, subtracting, constantly finding common denominators, or in adding and subtracting and dividing decimals. Much easier to deal with integers. So that's why we do it. It's just faster and easier, and there's less chance for the more complicated a problem is, the more chance there is to make a mistake. So we want to make it as easy as possible on us. The math is all about finding the answer in the easiest way possible. Okay, so let's do this first problem. I'll show you how to do it. Okay, so we've got 1/7 x minus 5/7 equals 3/7. Alright, so to clear those sevenths, I'm going to multiply both sides of the equation, because remember, we have to do the same thing to both sides, even when we're clearing the decimals. I'm going to multiply both sides, in this case by 7, because there's only sevenths. So I'm going to multiply 7 times 1/7 x minus 5/7 and 7 times 3/7. Okay, so this becomes a distribution, right? And you can do these fraction parts on the side. So 7 times 1/7 is the same as 7 over 1 times 1/7, which gives you 7 over 7, which equals 1. Okay, so we'll put 1x, or just x. And then the other one, 7 times 5/7. 7 times, it's a negative 5/7. Let's not forget that. Okay, again, 7 over 1. This time I'm cross-canceling. I would have done it the last time. Okay, so that's 1 there and that's 1 there. So 1 times 5, or negative 5, is a negative 5 over 1, or negative 5. So x minus 5, whoops, x minus 5 on this side. And then we have on this other side, we've got 7 times 3 sevenths, 7 over 1 times 3 sevenths, cross cancel, gives me 3 over 1 or 3. So that becomes 3. Okay, x minus 5 equals 3. Now I'll add 5 to both sides, right? And we get x equals 8. Now if you notice, if we stick it back into our original equation, we've got 1/7 x minus 5/7 equals 3/7. Okay, so 1/7 times 8, which is 8 over 1, minus 5/7 equals 3/7. Okay, so we would get here, if I multiplied these two, I would get 8/7. So let's just make it 8/7. 8/7 minus 5/7 gives me 3/7, and 3/7 equals 3/7, so it's correct. X is 8. In the case of problem B, we have 2/3 x minus 1/6 equals x. So the common denominator, now here we have two different denominators, we have 3 and 6, so we have to find the least common denominator. And of course the least common denominator is not going to be lower than the largest denominator. So it's going to be 6 or greater. If you think of their 2 times tables, 3, 6, 9, 12, well, they come to 6. 6, the first number is 6, 12, 18. So 6 is the common denominator. So that's what we multiply both sides with, and that will clear our fractions. So again, 6 times 2/3 x minus 1/6 equals 6 times x is 6x. Okay, so the distribution again, there and there, and again we could do the multiplication over on the side. 6 over 1 times 2/3 is, for you people who don't cross cancel, 12/3, which equals 4. 12 divided by 3 is 4. Okay, so this is 4x, because we multiplied the number times the number, but we have to, don't forget about the x. Okay, now we have 6 over 1 times a negative 1/6. So our answer is going to be negative, right? And I'm going to cross cancel this time. Divide 6 into that one is 1, and 6 into that one is 1, and we get a negative 1. So that's negative 1. And I already multiplied the 6 on this side, so I've got 6x. And you don't want to forget, you got to do it on both sides. Otherwise, you know, the scale becomes unbalanced. So we could put all our x variables on the left side. It's okay. I would move them to the right. I mean, I would try to get them on the right in this case, because the 6x is bigger. But it doesn't really matter. So I'm going to add 1 to both sides. We have 4x minus 1 plus 1 equals 6x plus 1. And that gives me 4x equals 6x plus 1. And then I'm going to subtract 6x from both sides. 4x minus 6x equals 6x minus 6x plus 1. And that gives me a negative 2x here equals 1. Divide both sides by negative 2. And that gives me x, because the negative 2 is over here. Cancel each other out, become 1. So we have x equals a negative 1/2. If you want, you can try these other two problems. They're problems from the book, and they're odd problems. So the answers for the odd problems in the book are in the back of the book. Okay, here we are, clearing decimals from a linear equation. Now, so last time we cleared fractions. Fractions and decimals really are the same thing. They're just a different way of writing them. They're parts, right? For instance, 1/2 equals 0.5, right? 0.75 equals 3/4. It's just a different way of writing the same type of thing. In a way, decimals are digitized. You can say like they're parts of 100, and or parts of 1,000, parts of a million. They're all in tens or tenths. A tenth of a tenth of a tenth of, or 10 times 10 times 10 times 10. Fractions are more exact though. Alright, a quick lesson on multiplying times decimals, because that's what we do when we clear decimals. So if you have 1/10, which equals 1/10, right? If I take 1/10 and I multiply it times 10, that would be 10. It would be like this. It would equal 1, right? So notice here, if I have 1/10 and I multiply it by 10, well, we're going to get 1 also, right? Because it's the same thing. 1/10, 1/10, both multiplied by 10, you get 1. Now notice what happens to the decimal point. If you multiply it by 10, there's 1 0 here. Multiply the 10 times the 10th, and you move the decimal place 1s to the right. That's all it is. So if, for instance, if you have 0.23 and you multiply that by 10, then you would move the decimal point 1 place. See, so it would be 2.3, 1 place to the right. You're multiplying it by 10, see, so you're making it bigger. If you were dividing it by 10, 2.3, and you were dividing it by 10, you would go the other way because you're making it smaller. You just move it 1 decimal place the other direction. See? So when you're multiplying by 10, you move the decimal point to the right. So let's say I have this number 0.0975, and I'm multiplying that by 100. Now there's 2 zeros in 100, right? So I'm going to move this decimal place 2 places to the right. So it's now 9.75. So it's actually quite easy to multiply by tens. It's actually much easier to multiply tens, in a whole number. Like for instance, 9 times 10 is 90. We just add a 0 on. With decimals, we move the decimal place 1 place. So you can see where understanding your decimals and your fractions is going to be a big help. And so if you're fuzzy on them, then you need to get a little practice doing it. Okay, so we have this problem. 0.2x minus 0.7 equals 0.4. So now notice there's all just 1 decimal place in each one of them. They're all tenths. So if we multiply all of them by 10, it'll move that decimal place to the right 1 place, and you'll have all integers. So let's do that. We'll go 10 times 0.2x minus 0.7, and we'll go 10 times 0.4. Okay, and again, distribution, right? So 10 times 0.2 moves the decimal place 1 place. It gives us 2x. 10 times a negative 0.7, we move it 1 place, so it gives us a negative 7. 10 times 0.4, move it 1 place to the right. By the way, make it bigger. It gives us 4. So now we've got a simple problem. 2x minus 7 equals 4. Add 7 to both sides. We get 2x equals 11. Divide by 2. Those 2 into 2 is 1x. So x equals 11 over 2. That was fun, wasn't it? If for some reason your answer had to be in decimals, well then you would take the 2 and you divide it into the 11. 2 into 11 goes 5 times. 5 times 2 is 10. 10. 2 into 10, we have to bring the decimal point straight up. 2 into 10 is 5 again. 5 times 2 is 10. Done. It's 5.5. So that, if you have to make it as a decimal, because we started out as decimals, so 11 halves equals 5.5. Problem B here, you can see that we have hundredths place and we have tenths place. So the least common denominator, if you think about it, because we're dealing with hundredths, see, like for instance, this one is 1/100th. This one is 42 hundredths. This one is 2/10. So the least common denominator would be hundredths. See? So we'll multiply 100 times 0.01x minus 0.42, and we'll multiply 100 times this side, negative 0.2x. Again, now we have two zeros here, so we move it two places to the right. 1, 2, so that's 1x or just x. This one, move it 1, 2, 1, 2. No x in there, so it's just a negative 42. 100 times this, we've got to move, even though we only have tenths, we've got to move it two places. So that would give us a negative 0, and move the two places would be, put a 0 in there, so it would be 20. Maybe you should do this over on the side. 100, if you did 100 times 0.200. You could do it this way. And 1 times 2 is 2. And then you count the decimal places, it's 1. Notice? Still get 20. So it's a negative 20. So we have x minus 42 equals a negative 20. We add 42 to both sides. X minus 42 plus 42 equals negative 20 plus 42. And that gives us x equals 22. Yippee. So I've noticed that a lot of students have trouble with clearing the fractions and clearing the decimals, so you have to get a lot of practice doing this. And once you get some practice, you'll see that this is the easiest way to do these problems, and actually you can get them done fairly quickly. And, you know, get the nuisances out of the way. Equations with no solutions are infinitely many solutions. When we solve an equation, a linear equation with one variable, we're going to have three possibilities. One we've already seen, where we have one answer. Well, we're going to end up with x equaling 5, or x equals some number, or a fraction, something. But the other two possibilities are no solutions, or infinitely many solutions. This problem here is one with no solutions. Look at x equals x plus 1. Can you think of any number that x could possibly be where this is going to be equal? So no matter what number you stick in there, it's not going to be equal. You stick 0 in there, it'll be 0 equals 1. For instance, I'll stick 0 in. 0 in for x. 0 equals 0 plus 1, which is 0 equals 1. So that doesn't work. It's just not equal. You know, if you get an equation like that, if you find that when you're done with the equation, you get something that's not equal, like if you get 5 equals 7, then it's no solutions. You can usually spot these early on. If you see the same thing on both sides, but one thing that's different, like if you see x, let's say 3x plus 7 equals 3x. Well, it can't. It can't. Because you know, there's nothing you can stick in for that x. The other one is here, like 5x, and 5x equals 2x plus 3x. You're gonna, when you combine like terms, you're gonna get 5x equals 5x. In this case, it doesn't matter what you stick in for x. No matter what it is, it's going to work. Everything works, from negative infinity to positive infinity. Rational, irrational, it doesn't matter. Everything works. It's basically, if you divide both sides by 5, in this case, you're going to get x equals x. So whatever you put in for x, it's going to equal. So that one's infinitely many solutions. So you need to be able to recognize this. When they're not equal, when they can't be equal, then there's no solutions. Let's do that in red. No solutions. No solutions. When both sides are equal, whether it ends up being 5 equals 5, 9 equals 9, 2x equals 2x. When both sides are equal, there are an infinite number of solutions. Okay? And then, of course, the third possibility is there's going to be one solution, which is going to be most of the time. That's mostly what we're going to be dealing with. But you have to be aware of these other two and be able to spot them. You have to recognize, because this will be a problem on the test. Say is it one solution, no solutions, or infinitely many? And usually it'll say, let us know if there's no solutions or infinitely many solutions. So let's look at a few problems here. Here we have 3x equals 2 times x plus 1 plus x. Okay, we solve the distribution first, right? And we get 3x equals 2x plus 2 plus x. Combine like terms, we get 3x equals 3x plus 2. Okay, that can't be equal. There's nothing that's going to work in that. No solutions. Can't be equal. Okay, let's try another one. Here we have 2x minus, parentheses, x plus 1 equals x minus 1. Okay, we have a distribution here too. Remember, 2x minus x plus 1 would be the same as negative 1 times x plus 1 equals x minus 1. Okay, so we have 2x. We distribute this negative 1 over those two. Either that or you can think of negating everything inside that parentheses. And you get negative x minus 1 equals x minus 1. Okay, so now we're going to combine like terms. On the left-hand side, we can anyway. 2x minus x is x minus 1 equals x minus 1. So you can spot it now. See, it's exactly the same on both sides. So there's infinite solutions. You could add 1 to both sides if you wanted to, and you would have x equals x. Okay, so that's infinite. All right, our last problem. 5x, if you have room on here, equals 2 times x minus 4. Oh, now I think you should stop it and work this problem out. Determine how many solutions there are. Okay, since you're back now, assuming you did it, we have 5x. We'll do the distribution here. We get 2x minus 8. Okay, then we're going to add a negative 2x to both sides to get our variable terms on one side. So we have 5x minus 2x equals 2x minus 2x, its opposite. And we end up with 3x equals negative 8. And then I ran out of room. We divide both sides by, I think I'll bring it back up here. We have 3x minus 8. Divide both sides by 3. That cancels out and we get x equals a negative 8/3. Okay, there we go. One solution. One solution. Okay, so no solutions. The result is an equation such as 4 equals 0 or 3 equals 2, which is always false for any value of the variable. One solution. The result is an equation such as x equals 1 or x equals negative 12, which is true for only one value of the variable. And then infinitely many, where the result is an equation such as 0 equals 0 or negative 3 equals negative 3 or x equals x. It's true for any variable you use. Summing things up, before we go into that worksheet again that we were working on in 2.1, linear equations, having trouble talking, in one variable can be put in the form ax plus b equals 0. 2. solving linear equations with a table. Sometimes you can, sometimes you can't. Actually, it's important to know where to start with the numbers. Get some idea of where you should start. Like if I started at a -100, it would have been a mighty big table. Number 3, solving symbolically. Use the 4-step process. You clear parentheses, do the distributions, use additive property and multiplicative property of equality to get a positive x, a variable. You want the x to be positive, x equaling some number. And then clear the fractions and decimals. And there are 3 possible solutions: 1, none, or infinitely many. So you want to know what they look like. Alrighty. Okay, now back to the stormy day group activity. We made our table from, remember it rained 3 inches before noon and then ½ an inch every hour after that until 6. So we have our table going from 0, which is noon, up to 6 o'clock. And then we have the rainfall that accumulated because of it. And from that we made our formula, which is r equals 0.5x plus 3. And we calculated the rainfall at 3 p.m., I believe. And it was 4.5 inches. And yes, it agrees with our table. So now we have to use the graphing calculator to make a table using the formula in B. Formula in B, which is actually the formula in A. So that formula, of course, is r equals 0.5x plus 3. So let's do that. So we're going to enter this into the calculator. R equals 0.5x plus 3. Of course, we're not going to enter the r. The r is going to be the y. So it'll be there we go. In for y. You're going to see, you're going to push y, and there will be a whole series of y's going down. So on the calculator, push the y. I'll show you a picture of it. There we go. Okay, so you push this button, y, and this screen appears here. And in there for y1, you're going to put 0.5x plus 3. Then you're going to go to this screen, and this is the table set screen. Push this button and then this one. Notice at the top in the blue, it's table set. And you're going to set it up just the way I have it here. Table start, you can't see it here, but it's 0. It's 0 for there. The change, this triangle, change in table is 1. And here for independent, if it's on auto, you push return and it'll go, or push right button, it'll go to ask. And for this one, put on auto. Then to get to this screen, again you push second, and then this right here there's the word says table, but you can't see it. And this screen will appear. Now it may not have many numbers on it, so up there where you put it up where it says 0, and then push enter, and then it'll go to 3. And then you go down, push 2, and so on until you add all these numbers from 0 to 6, and then it'll automatically put in the y's. You may have to mess around with this a little bit, but this is where the numbers are entered. If they don't all come up automatically, then enter them here, and they'll turn up on the screen. Okay, last 2 questions. And by the way, you should try to do these without my help. Okay, how much rain has fallen by 2:15 p.m.? So again, 2:15, that's how many hours past noon? Think about it. Turn it off. Turn it back on. Okay, 2:15, well, 2 hours and 15 minutes. It'd be 2 1/4, some people say. So 2 1/4 would be 2 1/4. Or as a decimal, if you transfer that into a decimal, it's 2.25. So our equation, R equals 0.5x plus 3, we'll put in 2.25 for our time. So R equals 0.5 times 2.25 plus 3. So we would get 1.125 plus 3. And that would equal 4.125. So that comes out to 4.125 inches, 4 in 125,000 inches, very close to 4 inches of rain. Okay, and then the last question, problem E, at what time did the amount of rain equal 3.75 inches? So, what time did it equal 3.75 inches? Well, that's our R, how much rain, 3.75, and then you just figure the rest of this out, right? Now that we know how to work these equations, what do? Figure it out. So what time is 1.5 hours? Well, it's 1:30 p.m. And that wraps it up. Okay, so now either go back and work some of those problems that I worked, just to make sure you understand them. Stop it and work the problems, and then look at how I did it. If you're ready, though, go and do the homework. Do the 2.2 homework. Now's the time, rather than wait till later when you've forgotten how to do it. All right? And I'll see you in class Wednesday.